Hey, 8th grade. So, welcome to the first benchmark review day for science. We're going to start talking about some different chemistry things. It's been a little while since we've touched on, so we're going to do a quick review on those. There's two types of properties when you're talking about things, and one is physical and one is chemical. And when you talk about physical properties, these are the ones that you can observe or measure without changing the identity of the substance. So, examples of physical properties include color, odor, texture, density, mass, volume, magnetism, and there are, of course, others. Chemical properties describe matter based on its ability to change into a new substance with new properties. So, this includes flammability, reactivity, anything that has to do with a chemical reaction and it's changing into a new substance and its ability to actually do that. So just like there's two properties, there's also two types of changes. There's chemical and physical changes as well. And a physical change is a change that results in the same substance and it can easily be reversed. So an example of this might be tearing, cutting, dissolving something, melting, or freezing. Chemical change is a change that results in a new substance, and this cannot be reversed. So this might be burning, rusting, digesting, baking, or fizzing something. Chemical changes are also known as chemical reactions, and the ingredients of a reaction are called the reactants, and the end results are called the products. Chemical reactions are processes that involve the breaking or making of bonds between atoms in order to transform a substance into another substance. So you have reactants leading to products. So these reactions involve the chemical change of atoms and molecules. So you'll notice that we have separate molecules over here, separate atoms. As they combine, we now have a different substance over here, which is our product. When we talk about reactions, there's a couple different types of reactions. One we talk about is a thermic reaction. And thermic means heat. And any reaction that's labeled with thermic deals with heat, which is a type of energy. So there's two types. There's exothermic and endothermic. And we talked about this exothermic energy and endothermic. So in an exothermic, this blue line, you have the products and the energy is very high, and then you lose energy or heat, and the products become very low by the end of the reaction. In order for an endothermic reaction to occur, heat has to be put in, and you have these starting products or reactants, undergoes the reaction, and it's an endothermic reaction because there's more energy after the reaction takes place. In an exothermic reaction, heat is released from the particles into the solution. So the solution becomes warmer. Exothermic, exo, exit. Heat exits. And heat always moves from hot to cold. So just another glance, you have this average energy of the reactants, a little bit of activation energy required or heat, and then the average energy of the products as it goes through the reaction. Endothermic is when heat is absorbed into particles from the solution. So the solution itself becomes cooler. Heat enters in an endothermic reaction. Endo means enter. Exo means exit. Endo means enter. And in an endothermic, you have this average energy of the reactants. You need all of this energy to be in place in order to get to the product. So it enters. So when we talk about the rate of a reaction, we're talking about how quickly a reaction occurs. And there's a lot of different factors that influence reaction rates. And some of those are the particle size. The smaller the particle size, the faster the reaction rate. Or in the temperature. The hotter the temperature, the faster the reaction rate. Go ahead and move on to the practice problems in your packet. Once you have finished that, you may be on Quizlet.